All right, so welcome to your first lesson of geometry today. And so we've already completed our scavenger hunt. And so we've put some terminology, some phrases, some different concepts into your mind about what is geometry and the things that encapsulates, all right, as far as the things that we're going to discuss this year. Now, what this lesson is going to focus on are what we call the building blocks of geometry. All right, and so you can see that we're going to look at several different standards today. So standard 1.1, I can identify and name lines, segments, and rays. Standard 1.2, I can identify and find points that are collinear and non-collinear. Standard 1.3, I can find the measure of segments using my knowledge that the sum of the parts of the segment will always equal the whole. All right, and standard 2.1, I can identify and name planes. And standard 2.2, I can identify and find points that are coplanar or non-coplanar. Now, I know that's a lot of vocabulary, and that's really going to be the challenge with geometry for most of you, all right, is learning that vocabulary and managing the vocabulary. So hopefully the things that we do throughout the year will help you with that. Now, most days we will have some type of opener. It could be an exploration, it might be a practice problem, it might be a recap of something previously learned. But today what this is, all right, is what geometrical elements can you create from 2 points? So if I just give you 2 points, right, whatever 2 points you want to label those and call those, right, what can you create from 2 points? And typically what we want you to do with the opener is that we'll pose this problem to you. We want you to pause the video, attempt the opener, and then flip the video back on to see kind of how your thoughts, all right, compare with our thoughts as we go through the opener. Now, once again, we may not be exact, but hopefully you understand some things, right, and you see some similarities in the conversation. So once you do that, draw some sketches and to illustrate your thoughts on what you can create. So go ahead and pause the video, do the opener, and flip it back on, and let's see what you have. All right, so hopefully what some of you said was that if I have 2 points, I could draw a line through those 2 points. So I'm just going to call these 2 points X and Y. So I can just draw a line through those 2 points, right? Maybe some of you said, well, if I have 2 points, I can just draw a line segment. Maybe some of you said, oh, if I have 2 points, I can draw a ray, and maybe your ray went this way, all right? And maybe for some of you, your ray went that way, all right? So those are really kind of the main things that we think about when we have 2 points, right? I can create a line segment, a ray, all right, through those 2 points. Now, maybe you came up with some different things. If you came up with some interesting things, be sure to share those in class tomorrow as we go through this. So now, moving on, all right, from the opener, all right, now we have to take some of these ideas, and what we want to do is start talking about vocabulary and notation, and that's really big in geometry in the same way that a lot of your notation and things are important in your LA class, right? There's certain things that we do that represents certain things. So there's a difference between a period at the end of a sentence, and there's a difference between an exclamation point at the end of the sentence. And then you're going to see those types of things with some of our notation in geometry. So the notations will tell us exactly what we're talking about. So there's notation is different for all three of these things, line, segment, and array, even though the 2 points are the same, X and Y. All right, so now, in geometry, we kind of think about some undefined terms. So geometry is really creating a set of rules that we're going to kind of work within, all right, to find different relationships. And three of our biggest undefined terms were point, line, and plane. All right, and so we understand what a point is, right? It's just a representation, that like infinitesimally small piece, right? And we just put like a little circle, a little dot to represent that point, right? Okay, now how do I represent a point? Typically what we do when we represent a point notation wise is we put a capital letter by that point. All right, so we say point A, point B, and we use just our normal alphabet, all right, and you see those letters like that. Now, how many dimensions does a point have? Well, technically a point has 0 dimensions because I can't go anywhere. So if I'm on the point, I can't travel. There's no direction I can go, right? So that's why there is 0 dimensions, all right? A line, okay, so a line, all right, and I'm just going to use A and B again here, all right? So a line, all right, looks like that, and it goes on in each direction, all right, for an infinite amount of time. It never ends, right? So it's going to keep going in this direction through B. It's going to keep going this direction through A. Now, how do we represent this? All right, so there's really two ways. Most of the time, we're going to use 2 letters on that line, and it could be any 2 letters on that line. So, for example, I could do AB. Let's say there was a third letter here. Let's say C was over here. All right, I could say that this was line AC as well, or I could say it's BC. Those would all be the same. All right, so it's kind of like when you're traveling through a city and you're on the same road, but it just changes name, right? So it goes from Main Street to Highway, whatever, right? those kind of ideas. Now, the big thing is the way I represent this is with a line over the top. So that tells me it's line AB or line AC. All right, so we usually use 2 capital letters and we put the line symbol over top. Now, occasionally what you will see, all right, is you might just see something like this, and sometimes you'll just see a lowercase letter like line L, right, or line N. And typically we only do that and if things are getting complicated, or maybe there's one line, all right, so you will see that as well. All right, now how many dimensions does the line have? 1, all right, because I can just go one way. So think about it, I can go right or left, right, but I can't go up or down, right, so I'm only going, all right, in one direction here. All right, so now, a plane. So when we think about a plane, right, I think of like a piece of plywood, an index card, the floor, the ceiling, that's a plane. And the difference between a plane and like an index card, a piece of paper, your floor, your ceiling, is that just like a line, it extends and goes in each direction for an infinite amount of time. All right, never quits, all right, going. So once you've defined that plane, it just kind of keeps working, it keeps going in that direction. Now, typically what we do when we have a plane is typically there's points in a plane. All right, so A, B, C, D, and we pick any 3 non-collinear points to define that plane. So like A, B, C. And non-collinear means they're not on the same line. Because if it's on the same line, all right, if I take my pencil, right, and this is a plane, so if they're all on the same line, there's a plane, but we get an infinite amount of planes because we could rotate, all right, through those 3 points. So we need that third point to be off the line, all right, and that's kind of what determines that plane. All right, so we typically use any 3 letters. And once again, a plane can have multiple names in the same way a line can have multiple names, right? So ABC could be a name of this plane, right? BCD could be a name of this plane, right? I may not pick ACD because those almost look like they're in a straight line. So I might like, maybe I'll go ABD. All right. Occasionally, we will use just a capital letter, one singular letter. All right, so maybe in a complex picture. So if I look at some of the problems that we're going to do in just a little bit, right, you can see here that they have a capital letter here in the corner, and that's plane M. So that would be like this plane right here. See a capital letter here? That's plane N, which is like this plane right there. All right, so sometimes, all right, we can use a single capital letter. All right, and then a plane has 2 dimensions. All right, so if you think about walking in your room, right, I can run front and back, I can move side to side. So that's your 2 directions. But as soon as you go up, you've now added a 3rd dimension. All right, so that's why your room is 3-dimensional. All right, but a plane, I can walk front and back, I can go side to side, you know, I can go at a diagonal, which is kind of a combination of front to back, side to side, but I don't go up or down. All right, so that's why it's 2-dimensional. All right, so let's go ahead and flip the page here, and let's go through a few more terms here. And so we've already talked about a line, right? So I'm not going to repeat that, but all right, I'm just going to draw it here. So we know that this is line AB. All right, so now the difference between a line and a line segment, right? My pen is a line segment, it ends. It has a defined ending, all right, and starting point, right? So that's a line segment. So even though, right, I have A and B here like that, right? So I still use 2 capital letters, but now I put the line segment over the top. And that's how I define the difference between a line segment and a line. And that's important, right? You know, versus, hey, right? Difference in your exclamation point versus a period, right? Or a question mark, right? So we want to make sure we get that notation right, okay? Because it really has a big impact on our meaning. All right, and you could still do that on this, right? So even if I had a line here, right, and I see AB with this over time, that means I'm only talking about this part. I'm not talking about the stuff past B or past A in the opposite direction. All right, so ray. What is a ray? Well, a ray is something that starts and then keeps going in one direction. All right, so for example, if I look at this line, I could have ray AB. And what this tells me, and when I put the ray symbol over the top, this tells me that it starts at A and it goes through B. So it's like I'm ignoring that part of my drawing. Now, if I had this, AB, and it was like this, that means it starts at B and it keeps going forever through A. So that basically means I would be, all right, ignoring this part of the line. All right, or you could draw it like this, right? I could do this. B, A, like that. That means I start at B and I go through A. So notice those two things have, all right, different meanings. So we want to make sure we put the correct one on top. All right, so now 4 more terms, and then that'll be it for our video for today. All right, so collinear. Collinear. So co means, all right, we share something. So collinear means we share the same line. So this means points on the same line. All right, so if it's collinear, that means they're all in the same line. So my example of collinear is kind of like what I did before, right? So there's A, B, C, D, right? So those are all examples of collinear. They're all in the same line. So non-collinear then means not all the points are on the same line. Not all the same points are on the line. Not all the, oops, let me do that, points are on the same line. So now if I just draw this picture, so we have A, B, C, but then D is way over here, right? So A, B, and C are collinear. They're all on the same line, but A, B, C, and D, non-collinear. A, B, and D, non-collinear. B, C, and D, non-collinear. All right, so now last 2 terms here. Co-planar. Once again, co means to share something, right? So if we're co-chairs or we're co-captains, all right, or whatever, right? So we're sharing. So co-planar means that they're all in the same plane, all right? So points, now, because we're in a plane, I'm going to put this points and or, right, lines, right, segments, rays are all in the same plane. All right, so all in the same plane, right? So, and once again, the way we typically represent a plane, we just draw like a little, all right, 4-sided figure, kind of like a parallelogram, if you know that term, right? And so there's some points, and maybe I have a ray right here, right? I've got a line over here, all right? So all those are in the same plane, all right? So those are coplanar. All right, so non-coplanar, well, that means not all in the same plane, right? Whatever you're talking about. So they're not all in the same plane. Now, the way I kind of think about this is thinking about like walls and floors, right? So you may have a picture, right, on one wall, right? You might have, your shoes on the floor. Those aren't in the same planes, right? So you can kind of visualize that, right? Or think about like floors in a building, right? So you might have, multiple floors like that, right? And so I might have this guy's in this plane, I have this line in that plane, right? And no matter which way I move it, I can't get them into the same plane, all right? So there's a lot of vocabulary. Now what we're gonna do when you get to class is then we're gonna start looking at, all right, some examples of how we use this information and work with that a little bit more. So I look forward to seeing you in class.